So for this first pattern, I started you off with a smaller version when we first started, but then I gave you some additional numbers here for the same pattern. Now, as you take a look at this, a lot of the normal strategies don't end up working too well. Because, like, what are you adding each time? It looks kind of good for a little while, like plus 0, plus 1, plus 2, but then plus 3. This isn't really a pattern. There's nothing consistent happening in this set. So we don't have enough to go on there. So then, okay, what about multiplying? Well, that's times 1, that's times 2, that's times 1.5. This is times 1.6 repeating. That's already getting very awkward. So multiplying doesn't work. So that's what makes this pattern so much harder. But like a lot of patterns, once you see it, then you can get it. And I would say start this pattern here, at that 2. Notice how the 2 is related to the numbers before it. How is the 3 related to the numbers before it? How is the 5 related to the numbers before it? You start to see it? So for instance, the 5. What about 8? Okay, how do I get to 13? Notice we just are adding the previous 2 numbers to get the next number. It's tricky, right? But once we see that, then we can go ahead and figure out what the next number in our pattern is. 21 plus 34 gives us 55. So this is practice from yesterday's work. We saw how to do these then. A quick refresher. Remember, when we write f of x, that means that whatever's in parentheses is our x value. And so this 4 is in the parentheses right now. That means that in order to figure out what f of 4 is, I'm going to take that 4 and plug it in for x. So I'm going to end up doing 10 times 4 plus the 9. Because if I'm plugging the 4 in here, that means I have to plug it in for x everywhere. Once you see that, hopefully then it's easy. Because we end up with f of 4 equals 10 times 4. That's going to give us 40 plus 9. And so then f of 4 equals 49. And that would be our final answer. And a refresher here, a reminder. Remember that this f of 4 is all notation. That does not mean f times 4. It means f of 4 with that function notation. So there's no like dividing or anything like that we do here. This is the final answer, and this is how it perfectly should look. So then, having seen the equation, here's that same table that we were using yesterday. It's the same table, so you don't need to recopy down the table if you're following on your same notes. And it's asking us to find f of 0. So look at the table for a moment. Figure out what would f of 0 be. It should be a quick one to answer here. Because when you're given the table, it's really just a matter of looking up the value. The trick is just making sure you're looking it up in the right place. So in this case, when we write f of 0, remember that means that the x value is 0. Because remember, it's f of whatever is x. So it's stuff in parentheses, that's your x. And so it's saying, look in that x row for 0. Well, and that happens pretty quick, doesn't it? That happens right there at the start. So when x is 0, f of x equals negative 2. And so f of 0 equals negative 2. That's it. That's a final answer. Great. Now we're going to apply that to graphs. This is the step we didn't necessarily take yesterday with the whole thing. But the function is going to work the same way. It's just a matter of seeing how. All right, so let's see how we would answer it then. So the first one, we're asked to find f of negative 5. Now, first of all, the negative 5. What does that represent in that situation? It is the x. And so basically here, by putting that negative 5 inside, we're basically saying x equals negative 5. Okay, so then I'm going to go over to my graph where x equals negative 5. Notice that's right over here. And I'm looking to see when does my graph hit negative 5. And so we can see that it happens right at this point. So if x is negative 5, what's the y value there? It's 2. Because we're going up 2. So the answer then, f of negative 5 equals 2. All right, now let's take a look at the second problem here. In the second one, we're asked to find x if f of x equals negative 5. Now this is where it's useful remembering that f of x is just a fancy name for y. If you like, you could actually name this y-axis as the f of x axis. So it's basically saying when that y value is negative 5. So we're looking down there and looking to see when does the graph hit that y value. And so you can see it happens right here. And so it happens to equal 2, which is a total coincidence that it gave us the same number. Didn't mean that, but hey, that's the way it works out sometimes. All right, so same graph, new problems this time. For that first one, it's asking us to find f of 0. The first thing I want you thinking about, what is 0? Is 0 like the x or is 0 like the y? It's in the parentheses here on this first one. And so whatever's in the parentheses, remember, that is x. And so it's basically saying our x-coordinate is 0. So we're right along this line here. So let's see where the graph has an x-coordinate of 0. Happens at that point. Okay, so what is our y-coordinate there? Negative 3. Therefore, f of 0 equals negative 3. Okay, how about for the next one then? We're looking for x if f of x equals 0. Now remember f of x, that's like y, so it's the same thing as saying y equals 0. So I'm looking here at where our points have a height of 0. Notice I just hit the graph twice. It happened both here, and it happened here where our y-coordinate was 0. So what happens? Well, you actually list them both, because that will happen on a number of different types of functions. And so the first place, the one on the left, it happened at negative 3. Okay, happens to be the same again. But then for that second point, that's at 7. And so x would equal negative 3 and 7. Those would be both the times when f of x equals 0. As you take a look at this situation, now we do the same thing, but you also can see through this example, also why function notation exists. One of the reasons. Because mathematicians and people who are using math to represent stuff graphically often end up with situations like this, where they plot multiple graphs on the same set of axes. And we have to be able to distinguish which one is which. And it gets a bit dull trying to call them all y1 and y2 and stuff like that. So we called one of these graphs G. Notice that's this graph up here. And we called the other graph F. Notice that's this one over here. And so knowing that, take a moment, see if you can find each of those three values, and heck, if you're finding this really easy, see if you can do that challenge problem. All right, let's take a look then. For that first one, we're asked to find the value of g of 3. Now again, we always start by asking ourselves that 3, is that the x or is that the y? It's in the parentheses, so yeah, it's x. And so I'm going to go to where x is 3. So we have 1, 2, 3 is going to be right there. And I look to see where does the graph hit that. Okay. Does it hit it at a nice pretty whole number? No. Does it have to? No. That can happen. A lot of graphs don't hit at just nice pretty whole numbers for answers. So what do? You make your best guess. You make an estimate. I'm going to guess that that's up at, now we got to count over here because it's like at about this height. So we got 1, 2, 3, 4 and change. So I'm going to call that about 4.8. If you estimated it as like 4.7, that's fine. If you estimated it as like 4.1, okay, that'd be a bit more of a problem. As long as it's something in the high 4s, it's a good estimate. All right, for the next one, we're looking for f of 2. So I go to where x is 2. because again it's the x value. Look, see where it hits the purple graph, because that's the graph of f. And it's asking me for the value of f. That is basically the value of y there. You notice we went down 2 to get to that point. And so it is negative 2. Next one, f of x equals 2. Notice in this case, the f of x equals 2. That's like saying that y equals 2. And so I'm going to go up to where y is 2, and I'm looking for that point on the graph. And so it hits right here. And again, I'm looking at the f graph. Okay, so then it's just a matter of what does x equal? And so I count over 1, 2, 3, 4. Looks like it happens over at 4. So there, x equals 4. All right, now that wasn't the only one I gave you though. There is one more, that challenge problem. And so how would we do something that looks like this? Don't worry, you're not going to be seeing a ton of those this year, but I think it's fun to see how this function notation gets used as you go higher. And this is one of those applications that gets used with function notation later. Quite a bit, actually. And it follows normal order of operations. So basically, in order to figure this out, you do the stuff inside of the parentheses first. So we start by figuring out what is g of 2. Okay, so I'm going to go over to x equals 2, and I'm going to see what the value of g is. So we go up here, and notice that that is up at 5. So g of 2 equals 5. Therefore, this equals f of 5. And then we can figure out what f of 5 is. So I go over to where x is 5. 1, 2, 3, 4, 5 on my x. And I look to see what the value of f is there. And you can see that the value of f, that is its height, looks like it's up about 4. And so that f of g of 2 equals 4.